relation of water quantity and also population. So how do we relate? Let's say if you want to treat water, okay, you need to know the amount of water to be treated. Okay, and definitely in order for us to estimate the water quantity, you need to know the population. So how do we estimate the quantity needed? Let's say you as a civil engineer, you would like to develop a new water treatment plant. You should know the capacity of water that they should um, treat to be given to the population. So how do we relate that? We will be using the geometric growth. Okay, the geometric growth. And the relationship is actually like this. R is equal to Pn divided by P naught, okay, to the power of 1 over m minus 1. So let's understand this equation or this geometric method. So R is actually the percentage growth of population. Okay, Pn. What does this Pn stands for? Okay, Pn is the population for that particular area. Let's say Johor Bahru. Okay, so population of Johor Bahru in the year N. Okay, let's say you are trying to develop a new water treatment plant. Okay, so we want to know the water treatment plant needs to cater the population in that area. Let's say in Johor Bahru, in what year? Up to what year? Let's say up to the year 3000. So that N should be 3000. Okay, divided by the population in that Johor Bahru in the year naught. The year naught means now. Let's say the year now is 2020. That means your P naught is actually P 2020. Okay? So you need to know the population in Johor Bahru in the year 2020. So let's say it's 5 million. Okay? 1 is 1 divided by m. M is actually n minus O. N minus O. Okay, so 3000 minus 2020. So you got is to be 80, the whole lot minus 1. And that is actually the population growth. Okay, so that is the population growth. So how is it related with the amount of water need to be treated? Right, from the formula of the percentage growth of population here, okay, you should be able to find out the Pn or the population of the year N. The information on the population of the year N is needed for us to estimate the water demand in the year N. Okay, this is the water demand in the year 3000 is equal to the population in the year N. So for our case, the population in the year 3000 multiply with the Cn. Cn stands for the water per capita per day in the year N. So for this case, it is the water per capita per day in the year 3000. Okay? Just now I told you that the water demand water per capita per day in the year 2020 is 280 liter per person per day. So it may change because of the characteristic of people may change. Okay, perhaps in the year 3000 people are more conscious, okay, about water. They want to preserve water. They don't really use water much. So the amount of water per liter per person could be very little, perhaps 180 liter per person per day. Okay, but perhaps at that time, okay, suddenly we have abundance of water, so people get, don't really worry about water. They just use their water as they please, and that amount of water could be 380 liter per person per day. And the last part is the service factor in the year 3000. Okay, plus the water demand due to something else. If you look at this formula very carefully, basically the water demand in the year N depends on the population in the year N And also plus the water demand due to something else. Something else means like, what about the industrial area in the year 3000s? What about the public usage like hospitals, place of worship like mosques, or um, temple and so on. Okay, and then for the fire purposes. Okay, so those are the water demand due to something else. If you have if you have let's say heavy industries or even uh, small industries and so it also will contribute to the water demand in the year for that year. Okay, guys. So yes, I would like to tell you on the service factor. What does service factor mean? So the service factor is actually like this. Okay. So let's say we choose the state of Perak. So look in the year 2014, in the urban area in Perak, the service factor is 100%. Or in other words, the service factor is 1. 100% means 100 divided by 100, right? So that means 1. What they are trying to say is everywhere in urban area in Perak, they obtain clean treated water. 100% people obtain clean water. But when it comes to the rural people, about 99% or 0.99% and 0.99, the service factor, receiving treated water. So the other 1% may not be able to get treated water, so they may resort to using water from from some other sort of water. Okay, from the river, for instance, directly they take the water from the river, so they use the water. That would be the case also. Look, this. So I think the clients people, okay, they are using the urban area, only 60% of them receive treated water. Does not mean that the other 40% don't receive clean water at all. Okay, they just don't get the proper treated water. They are probably using well water and they treat themselves. They perhaps use we use a certain coagulant like alum. They treat their own water. Okay, so it means. Yeah, and the service factor for Sarawak is 87. I've got the data just in 2019, 2009, and for Sabah is 77%. This data is in the year 2020, in the year 2000.